Next, we're going to hear from Christophe Beets from Imagination Technologies on accelerated augmented reality and how you can combine 3D graphics with augmented reality. Christophe?
Good morning, all. So I'm Christophe Beets. I work for a company called Imagination Technologies. We've heard the term silicon vendor a number of times this morning. Imagination Technologies is not actually a silicon provider. We're a hardware IP provider. What that means is we are creating a lot of the key building blocks that allow you to build today's highly advanced systems on chip. So what we provide is the technology puzzle pieces that allow you to put together an overall system. The market segments that we've mostly been focused on is on the multimedia side. So that means we look after graphics and video technology as well as processor and transmission standard solutions. What I'll be focused on in this presentation here is mostly our graphics technology, which you might know best under the brand name PowerVR. So Imagination Technologies is a company that's been around for over 20 years. It's the number 3 silicon IP provider out there. And you can see a wide range of the licensees that adopt that graphics technology today in the market on the left-hand side on the slide. And just to stress that market opportunity, this is just a wide range of the kind of mobile devices that already today contain our graphics technology. And there is actually more than 600 million devices out there that contain Khronos API, OpenGL, Opencl capable graphics cores that you can tap into from an augmented reality acceleration point of view. And of course, this is not just limited to the mobile space, but does also stretch into the consumer space where set-top boxes and other products ever increasingly adapt the same kind of functionality. So, as I said, the focus here is really on the kind of graphics side of things. So be very much focused on what the graphics processing unit in your application's processor can bring to augmented reality and the link to the Khronos APIs that are available today. The most obvious thing, of course, is you are trying to bring virtual objects, 3D rendered objects, into the real scene that you are capturing with your video device. And this is where the OpenGL standard helps you in terms of providing you access to hardware accelerated 3D rendering with ever increasing quality. The next key element is to be able to combine the video, the reality, with the virtual 3D rendering that you're doing with OpenGL. And as Neil just explained, this is really where the EGL interface, a kind of buffer management API between those different sources of data will help you. And finally, there's the key component of analysis, being able to look at the image data, the sensor data that comes into the system, and doing the heavy number crunching on all that information. And this is where Opencl, especially the embedded profile, will help you out on mobile platforms, because the key factor there is really power consumption. And we need to balance that between high-end server desktop systems versus mobile platforms. And this is where OpenGL, Opencl embedded profile, the focus on power consumption is really there. And in augmented reality, there's a huge amount of feature tracking, image processing, image enhancement that is happening. And that is really where Opencl gives you access to the parallel compute capabilities of the platform using the GPU to really bring the acceleration there. And from our point of view, all the different PowerVR, SGX, and Rogue technology products that are in the market or are coming to the market this year will start to help you. So looking at this in a little bit more detail, the key problem that we are trying to solve within augmented reality is video texture streaming. And there's a number of different levels you can do that integration. And what I've started here with on this slide is the simple usage case, which is very much the kind of green screen color key style technique where you basically just provide an overlay functionality. So on one side, we have the input from the camera, which is providing you with a real image of the reality that you are looking at. Now, at the same time, we want to combine that with the virtual 3D rendered images, in this case, a couple of cute little characters that we want to combine into that real scene. And the simplest way to do that is to use some of the display controller hardware that you will have in the majority of SoCs today. So this is really the driving block within the SoC towards the screen, and it can read in multiple components. So it can take the YUV data from your camera interface and combine that with the rendered image from your graphics core, which is typically in an RGB format, and mix those two together using the alpha information that is provided by the graphics core. So the key thing here from a power consumption and an efficiency point of view is obviously to avoid CPU involvement. So you do not want CPU copies of this data. You do not want color space conversions being done with the CPU because it's very expensive in terms of bandwidth and power consumption. The overlay mechanisms and hardware in a lot of the platforms today is very specific, so it's not trivial today to take advantage of that. And this is really where Khronos is providing you with the critical APIs to try and resolve that. But this is really the kind of entry-level functionality for AR processing. What we have on the following slide is really where we want to go to, which is a more complete integration of all this video streaming functionality. And this is really to allow you to take into account a lot more of the flexibility in the system. And what you see here in the change of data flow is that the camera image now is no longer going directly to the display controller, but starts to form input directly into the graphics core for processing. So this means that your camera YUV image becomes a direct input as a texturing source within the GPU. And this means you cannot just generate 3D virtual objects, you can also take the reality, the image that you are capturing with your camera, and you can start to process that. And what that, for example, allows you to do is start to bring into account things like parallax information, where objects are properly occluding other objects within the scene, or if you want to have an overall look and feel from a 3D rendering point of view, you can apply that same kind of toon rendering style to the reality image as well. Now, of course, this introduces a lot more complexities in terms of making this all work effectively. And this is where initially we've seen a lot of vendor-specific extensions. And you almost have to make the differentiation there between the GPU vendors who might have extensions, but also the OS providers who may provide specific mechanisms to access that. And Apple with the iOS platforms has a lot of custom mechanisms there, as well as Imagination for a long time has been providing extensions to make this functionality possible. And in the early days, this was very much to just accelerate your camera interface. So this is what allowed you to go and create a very fast and low power camera interface just for taking pictures. And obviously we'd now like to take that to the next level with augmented reality processing. And this is where the different EGL streaming interfaces that Neil mentioned before are really going to help this process to allow you to write applications once and deploy them across a much wider range of devices. Now, trying to make things a bit more interesting, I'm trying to bring in a number of examples here. So the first company I'd like to show you some video from is a company called String, based in the UK, and they're providing a lot of the engines into the kind of marketing and advertising market. And this is here the core technology in terms of mapping the kind of 3D objects and animations into the real world scene using a marker-based system that you see here. So you see how this character can be brought into the real world scene, seen on the screen of your iPhone in this case, and walk around your table very effectively. But this is very much an example of the simple overlay style of introduction. So what you see here is purely a 3D rendering overlaid with a kind of real 3D scene. but you can see already that the user can very easily interact with the system, interact with the creature within the real environment. And this is actually a demonstration that we're using on our booth here at MWC. So all the different technology stations that we have there have an augmented reality marker that you can use to get more information about our products. The second company probably doesn't need much introduction. So one of the very cool products out there that contains our graphics technology is the PlayStation Vita. And the game I've picked here is Reality Fighters. And Reality Fighters allows you to create your own character, and then you can bring it onto your own table or into your own backyard, and really start to allow those fighters to basically interact with the environment as well as with each other. One of the really interesting things, of course, is that you can capture your own reality as well. So you can capture your own facial picture and then map it onto the 3D rendering as well, and then just render it onto the parking lot in your from looking out of your window out there. So the really key thing is the picture on the left there in terms of being able to bring distortions of the environment into play. And that is really where you are using the streaming capability so that the GPU can actually distort the camera image as well to give you much more immersive and overall feel. And this is a lot clearer in the following demonstration, which I have from a company called Obvious Engine. So they've moved away from using trackers. So that means you do not have a card which you need to position in your scene, but rather they directly recognize objects, such as the very easy to recognize Dr. Pepper can here. And what you see is they actually go to that next step in terms of actually distorting the reality. So taking the can and doing a kind of distortion of the object in your scene. And the great thing now is that you see that actually the parallax comes into play and fully interacts with that scene. So you can really see all those interactions being fully user interactive and controllable as well. So this is really where ideally we want to get to as an augmented reality level, where there are no markers, there is just the reality around you, and the system can do very advanced interaction with this without needing anything special within the environment, just taking all the sensor data that you have, the image data from the camera, the gyro and other sensor information that you have within the mobile systems today. And again, here you see how the object, which is in the real world, is starting to occlude the 3D objects that we are rendering on the screen. So this is this kind of fully immersive experience that you can bring to the system by having the texture streaming abilities. And of course, the orientation of the device, horizontal, vertical, it really does not matter. Everything should track and be fully user-friendly there as well. So this brings me to the kind of second component where the graphics core can help out, and this is actually in the area of processing. So augmented reality, to create all the effects that you've seen in the previous videos, requires a huge amount of processing. And today that processing predominantly is assigned to the CPU because it's quite easy to port between platforms, and historically the CPU has been available to you. Now, one of the great revolutions that Khronos is trying to introduce is to abstract compute across multiple heterogeneous devices through Opencl. And Opencl is really one of the languages that will give you access to parallel compute. And this is very well suited to graphics cores. And this is what I've tried to capture in this slide is some of the key components for Opencl. Because very often we get asked, so what is going to be the killer application for Opencl for parallel processing on my mobile phone, on my tablet? And then you can talk about image processing, video processing, audio processing. Is it physics? You know, what's going to be the differentiator? And the real answer, we believe there, is that the answer is power consumption. Opencl will allow you to do a lot of processing, much more power efficient on a GPU than on the CPU. And what we're demonstrating here is the two colors we have. In the red, we have the CPU application, and this was a platform with dual-core Cortex A9 processors running at 1 gigahertz. So quite a high-end platform that is shipping in the market today. Now, when you're doing a lot of image processing and tracking algorithms for augmented reality, it's very easy to completely flood that CPU with processing to 100%, and that consumes a lot of power. Ideally, what we want is the blue bar, where we completely move that processing load away to more dedicated processors, such as the GPU. And that obviously has a much better impact on power consumption, because the GPU within this system, very much a mainstream GPU running at only 300 megahertz, so much lower in terms of power consumption. Now, the following series of bars that we then have looks at a lot of the typical image processing algorithms. And what you're seeing there is that despite the fact that that GPU is much lower clocked, so is much lower in power consumption, is actually delivering almost twice the performance of that dual 1 gigahertz CPU processor. So not only are you getting a complete offloading of the CPU, you're also getting much higher performance and throughput. Now, what does that then do to power consumption? And that's the final bars that you have on the slide here. So on this platform, we measured total system power consumption, and the difference between using the CPU for processing and the GPU for processing is almost a complete watt of power difference. So you have a lot of power saving while actually delivering double the performance. And that is really what we believe is the key critical application that Opencl is going to bring to your mobile devices. And this is fully possible today on the platforms, and we're demonstrating that on our booth here at MWC. And just to kind of show you some of that processing, one of the companies that we're working there is Accelerize, and they have an SDK to help you with a lot of that processing. So again, you're seeing here a very simple mainstream device that actually has been shipping for several years, and this is doing advanced image processing here. So it's recognizing contours, hitting different feature points within the image, and you can see this running here fully accelerated on the graphics core rather than on the CPU. So really giving you higher performance, but much lower power consumption on the system. And this is already running under Android here. So a lot of this, unfortunately, today is in prototyping stages, but a lot of this is being introduced much more at the application level, not as easily accessible, unfortunately. So you see the interactivity again, so being able to select different regions and then tracking them as you pan across the scene. So to wrap up, what I've done here is to just collect a lot of the resources that are out there, looking at all the various toolkits and middlewares and frameworks that are already available today across the two main application store platforms, so under Apple iOS as well as under Android. So a lot of the links to the companies of which I've been showing video material here, but also a lot of the other companies out there that are providing toolkits that are very good to use, because it's never useful to start to reinvent the wheel when somebody's already done all the integration effort for you. From a graphics core point of view, obviously Khronos provides a lot of resources for you, especially the API specifications, which is the biggest value that they're introducing, but also the support forums, the presentations such as from this event will be fully available there. If you're looking at specific PowerVR graphics core information, how to get the best performance from 3D rendering, or if you're really interested to tap into Opencl onto some of the existing devices already there, please do visit our PowerVR Insider ecosystem website, where you can download the latest tools to help you with development, as well as getting in touch with our support groups out there to help you get access to early platforms and early APIs. Of course, we're here at the show to demonstrate a lot of those functionalities, so please do come by our booth, which is in Hall 1. It's very easy to find, where you can look at a lot of these augmented reality demonstrations and 3D rendering as well as compute capabilities. what I would like to do to kind of conclude is to very much mirror Neil's request at the end, that is, feedback is absolutely critical for Khronos, but also for the hardware providers out there. So I was already yesterday talking to some of our partners on the booth, and immediately there was a lot of feedback that we can take back into Khronos in terms of real-world usage cases. Because while we are a graphics expert, there is a lot more opportunities out there for GPUs now because of Opencl, because of the programmable nature, and we are not experts at every possible usage case. So hopefully you are out there, the AR experts, so please do contribute the requirements that you have back to Khronos or one of the many members like Imagination Technologies. Let us know what you need to be fast, which kind of processing algorithms, what types of data formats you need, because only that way we can create the right hardware and the right API interfaces to deliver you low power, high performance, and great featured devices that will ultimately help us to push that market into the many millions and billions of devices out there. Thank you.
Thank you, Christophe. That was a really interesting overview of how to use the GPU for accelerating augmented reality. Next up, we have Enrique Philippe from ST Ericsson, who's going to give us some information and an understanding of how today's mobile platforms are both AR capable and how they're working towards optimizing them for AR functionality. Enrique.
Thank you. Hello, everybody. So, ST Ericsson is a young company, is a joint venture built by Ericsson AB and ST Ericsson 3 years ago. And we are silicon suppliers for the mobile market, selling complete platforms that goes into the tablets and smartphones. We develop the hardware for almost all the components that need to be hosted inside a smartphone and a tablet today. And we integrated those into very compact chipsets, which are built as application processors for mobile, called the Nova family, the Tor family of modems from 2G to LTE, and then the integration of the two into a single chip called the Nova Tor, which is the combination of the highest performance application processors and the up to LTE modem. So why we are investing in augmented reality, what we see is that modern chipsets are already very powerful CPU, GPU, video accelerators. But anyway, when we come to test augmented reality applications, we see that still there are a lot of bottlenecks and resources in the platform are not used in the optimal way. So, and that's why, because historically the mobile community has developed chipsets in a way that optimize for single use cases. So you get optimized chipset that can do very well video streaming, very high quality video recording, excellent mobile gaming, now close to the consoles. But when you put all things together and has to run concurrently, all these things, as it happens in augmented reality, the final result is not so good, because the communication and the integration is not built to run all these things together. And if the GPU is busy to manage gaming and animation, it's not easy to use it concurrently for rendering and overlays of the messages, and it is not easy to manage concurrently any video editing. So this is what we want to address and where we can really add value in this industry. On top of the problem of different way to use the resources, we also have to manage a bunch of new algorithms that has been mentioned before by the colleagues, and which are pretty CPU intensive and also very parallelizable. So In that, these new algorithms that are specific of augmented reality, like object tracking, feature extraction, object recognition, are very suitable for new generation hardware and new architecture in hardware. But the problem is putting new hardware is nothing if that cannot be exposed to developers. And the silicon vendors and the hardware architects alone cannot really manage to develop different solutions for any different chipset. So this is really where we strongly participate in the activity of the Khronos for the standardization, because this is really where we have a key enabler, not only to make the new hardware available to developers, but also to enable the community of silicon makers, including their GPU partner like Imagination, the CPU partner like ARM, to really have an healthy definition of the interfaces that make the collaboration and the integration of the platform much easier. So key technologies we are addressing, primarily from the hardware point of view and together with a lot of partners, are multi-core computing, switching to programmable general purpose GPU, and as a consequence, an heterogeneous approach to multiprocessing. These things are not specific of augmented reality, but we consider augmented reality as a use case driver for the evolution and the definition of the technology roadmaps. And then other technologies which are a little bit more specific enablers, like additional feature in camera and images that really make sense for augmented reality. For example, 3D tracking, 3D cameras are a little bit on a niche in terms of rendering system. Only few phones implement it, but almost all phones could exploit the ability to detect depth much more easier and make that information available to the applications, even if the display will not be 3D. And sensors especially, where we have an advantage to work with a parent company, ST, which is really the worldwide leader for MEMS sensors today. So we decouple the technology into two categories, the one which are general platform capabilities that need to be improved for augmented reality, and the other one which is the augmented reality specific hardware. And we try also to work with partners to test and explore different possible partitioning for the new features. As a matter of fact, today, most of the augmented reality applications are coming into the market as web applications. So some of the functionalities can be implemented in the network. You may do some recognition locally of the object, but then you may want to query an internet database to have a final confirmation what the place or what the object is. And for that, we are a leading provider of LTE capability embedded in the platform, coming soon at very affordable price. And this technology can be a breakthrough for augmented reality in the sense that to some extent all augmented reality applications need to launch query to some servers. The problem is the reactivity and the quality of the link. And most applications in augmented reality really need outdoor experience. You cannot rely on Wi-Fi or other cheap connectivity. So here LTE and broader deployment of LTE can be really a game changer and an enabler, because we'll allow better latency and better bandwidth to make the communication with the cloud much easier and much more effective for applications that really have real-time constraints. So quickly going into our technology roadmap for the computing architecture, we are clearly heading towards fully programmable resources. This means multi-core CPU. This means GPU and graphics that is much more programmable and can be used for algorithms different than pure graphics. And also our own multimedia accelerators are more and more programmable engines today. So for the GPU, we are also trying to follow up and enable and test at very early stage with our partners the efficiency of the various languages that are proposed today. where OpenCL is really interesting, being the only OS-independent and platform-independent solution available today, but it's not the only one, of course. And on the sensors, we have started adding in our chipset a very specific subsystem that will really increase the amount and the quality of the sensors that will be made available to developers. So that's reflected in our product roadmap, the Nova application processor family. We have started collaborating with augmented reality partners since the A9500 product. And in the new generation one, the 9540 that you can see now at our booth and our partner booth, and then the upcoming nodes, introducing more and more capabilities that will allow very complex video overlays, mix and match of graphics and video, and more sophisticated camera and sensor capabilities. As well as for the modem, we are going to have the cheapest and more compact LTE modem in the industry, which will also come integrated into single chip platform, like the 9540 Novator platform, which will really reach the same, very soon, the same cost point of the standard HSPA platform of today. So to quickly conclude, augmented reality is now one of the key drivers and application that we keep into account in our technology roadmaps for GPU, CPU, and connectivity. We have, thanks also to our network of partners, competitive advantage in very special silicon capabilities that will allow to achieve more MIPS at much lower power consumption, and will allow us to embed a very rich state-of-the-art complete set of sensors. And we are a system integrator, so we are a strong supporter of open standards like Khronos and in general open ecosystems. So we would be very pleased to host especially companies developing augmented reality applications to come visit us and possibly collaborate with us to test and pre-integrate algorithms so that we can identify bottlenecks at very early stage. And we can also give a possibility to test how the new nodes that will come in products in 1-2 years, what this will allow to the developers more than they can do today, so that developers can really think big and having some real understanding what will be available in terms of resources in the coming years. Thank you.
Thank you, Enrique, for that insight into what ST Ericsson is doing with augmented reality. Next on the agenda is Sri Kanani Iyer from ARM, who's going to give us an introduction to what ARM is doing with the augmented reality experience.
Good morning, everyone. My name is Sri Kanani Iyer. I am from ARM Cambridge, working in the media processing division, focusing on AR and user interfaces. See a lot of familiar faces today, so glad to know you all made it here. I hope to have a good time at MWC this year. I would also take this opportunity to thank Khronos and Neil for giving this opportunity to the AR community to share ideas and see where we are all going as members of this community. The topic of today's talk for me is more on the computing side of AR, what ARM has been doing and helping the ecosystem with. And of late, you've seen a lot of activity around, have we come to the end of the hype circle? Have we found the killer app? What's coming next in AR? In fact, there was also a small rumor recently that a small search engine company in California is going to have AR glasses by the end of next year. So it's interesting how the market is shaping up. But we at ARM have a slightly different perspective. We want to look at things a bit differently in terms of how AR has evolved over the past few years. If you look at the evolution of user interfaces, we have sort of gradually moved towards simple user interfaces like the keyboard, going on to a touch interface, then a gesture-based interface, something a bit more intelligent. So what you've seen over time is that we have slowly moved towards something which users want to interact with in a very intuitive way. And now what we see today in user interfaces is that you have interfaces where you interact more actively with the environment, immersive with the environment, and you get a lot of contextual information which could be based on gestures, a voice, or just natural interfaces. And we see AR as a part of this evolution. As we evolve from keyboards all the way to intelligent user interfaces, AR has, in a way, become integral to this evolution chain. So the key takeaway from this point of view is that AR is here. We know it works. There are a few challenges that we face, but AR is here, and it needs a bit of maturity, but it is really a part of this evolution of user interfaces as we look forward. Today, if you look at the smartphones, it has a lot of capability. It can do a lot of intelligent applications. And from what the other colleagues have spoken about in terms of the capabilities of the platforms today, you have all the smart technologies that you can have in terms of tracking, 3D graphics, high-end applications, feature recognition. All of these things run on a high-end smartphone. Yet the applications that you see today from the AR perspective tend to be a bit gimmicky and sometimes a bit disappointing. But that shouldn't deter anyone from thinking that AR has the bubble has burst or it doesn't have a future. You already see a lot of these AR applications deployed across several segments. For example, you can see AR in high-end gaming, which is gaining more and more sort of popularity going forward. You also see a lot of interactive applications where you interact with a magazine or something that's a bit more intuitive. What's even more interesting is how AR is shaping the shopping area in terms of how you shop for things in terms of, let's say you want to buy a diamond ring and you play around with the diamond ring without actually having a ring and it looks real. A lot of location-based AR and social media-based AR is becoming more popular. With the advanced computer vision technologies that you have on the phones today, navigation and security are gaining a lot of importance too. But like any other technology which goes through sort of a curve of growth and maturity, AR is also going up the growth curve, and it has to mature a little more before it gets accepted into a lot of devices going forward. From that point of view, I think it's important to see what are the influencing factors in AR today from a high level. We all know what AR is from all the previous presentations, but what is it that are the critical success factors for AR? So we've seen a lot of different people talk about sensors, networks, LTE, and so on and so forth. What does this mean in terms of AR? First of all, you need fast tracking and fast sensing. So when you move your device around, you want your environment to be tracked efficiently. You want the device to find out who's where, what's happening, and track the environment as soon as possible. That's responsiveness. Graphics, we've been talking about graphics quite a bit. Graphics are extremely important. In fact, you want graphics to be true to life. And in fact, this is, in a way, the reality part of augmented reality, that you want things in the virtual environment to look real. We've been talking about a lot of cloud-based infrastructure. So you're pulling a lot of data from the cloud. Some of that happens on the device. Some of that happens on the cloud. So dependence on the network is becoming more and more important. We live in an environment where we are surrounded by a lot of information. A lot of it is junk, but a lot of it is relevant. But it's important that when you present information to the user, that information is relevant to him in a small screen or a large screen. Again, UI, when talking about UI or intelligent UI, it is also important to immerse the user in that experience. So it's very important that in an AR experience that you create on a mobile device, the content plus the content that you present is immersive for the user. And last but not least is the ergonomics of the device. Is it going to be a phone going forward? Is it going to be a big head-mounted device? Is it going to be AR glasses, which look like Oakley glasses? So it also depends on how attractive these factors are. From ARM's perspective, we try to focus on the computing aspect of things. How can you run the system efficiently? And as you can see on this picture, it's not just how fast your CPU runs, whether it's a 1 gigahertz or 2 gigahertz CPU, or how good your GPU is. Am I able to do the best graphics rendering possible? It's really a system statement. The system has to come together and run efficiently to support all these features. And we at ARM have been looking more from a computing aspect of things in terms of how to make the system more efficient, how to make the user experience more rich in terms of augmented reality. And from that perspective, there are three things which come up as problems or challenges that we are now addressing at ARM. You must have noticed that when you sort of carry a phone around for about 5-10 minutes running an AR-heavy workload, the phone gets really, really warm. This might be quite comforting on a cold day, but it's not that good for the technology because the phone is going to heat up or maybe explode. You never know. So the battery life of this technology is extremely important, and we are working actively to address that. Responsiveness, tracking the environment, how quickly you can identify things is also important. But also important in the same context is robustness, that when you run an AR application, it has to be stable, it shouldn't fail you, and you want a sustained AR experience on your device going forward. Now, taking this to the next step, we know what the critical success factors are, we know what AR means. I want to just take you into a little bit more into what's happening on a CPU and a GPU and how we can address some of the challenges. And I'm taking here a small example, which is a bit representative. We've done some analysis on what an AR workload might look like. It is an example. An AR is a huge area, but I've taken a small example within this. Some of the speakers have spoken about what runs on a CPU, what runs on the GPU, and still a lot of the bulk processing is still running on the CPU, while the graphics rendering, the image compositing runs on the GPU. As you can see, within the CPU sector itself, there are different things that happen, feature detection and feature extraction and so on. And we've done an analysis of a very commonly used algorithm in this area called SURF, which shows the same trend, that the bulk of the processing is very CPU intensive. But if you take a step further down in terms of what's happening inside that algorithm, you will find out there's a lot of parallelism. There's a lot of computational intensity. So these are computationally intensive parallel algorithms which are running on the CPU. From an efficiency point of view that I've been trying to focus on, what is system efficiency? You want to focus on how to run the task on the best processing element in a complex system. And we've been talking about a lot of complex systems which consist of a CPU, a GPU, a memory, all coming together. So it's very important from an efficiency point of view that you run the task and match that task to the most efficient way of running the task on a processing element. And we at ARM have been working with our partners to build such smart and efficient systems. So, talking about smarter and efficient systems, ARM introduced you to a concept of big little CPU last year. And this is sort of essential to what efficient computing really means. In this kind of a system, in order to match the competing demands of sort of performance, scalability, and efficiency, you have a big CPU, which is inherently good at running highly demanding tasks, and you have a little CPU, which is inherently good at running less intensive tasks, so that you have a balance of high computation power at the same time, something that's not that computationally intensive. At the same time, what's essential to the running of this kind of an efficient system is a coherent interconnect, a cache coherent interconnect, which connects the rest of the system. Example, the Mali series GPU, which has been designed to make use of this coherent interconnect to put the system together and make the system talk to each other more efficiently, is the concept behind the big little CPU. What this means in terms of efficiency are two things. Now you have a system which consists of a big little CPU and a Mali T600 GPU, which is also capable of doing GPU compute. And you connect these elements together with a coherent interconnect so that the communication between these elements becomes very efficient. And once you have efficiency, you have lower power. The second aspect of this is because you are going less to the memory and communicating with these processing elements directly through the coherent interconnect, you consume less power and less bandwidth. So this goes back to efficient computing, again, low power. If I take this example of matching the right task to the right processing element and go back to the example of the AR application I had, this is an example of where a big portion of the application runs in the CPU and another portion runs in the GPU. But once you identify the parallel parts of the algorithm, the compute-intensive parts of the algorithm, and move that over to the GPU using the GPU compute paradigm, what you end up getting is a more balanced workload wherein you use the ARM coherent subsystem to offload some of the compute-intensive CPU tasks to the GPU using the GPU compute paradigm. And by this, you match the right task to the right processing element. And by doing so, what you get is more battery life and lower power consumption. This, in a sense, is how you get system efficiency, by making the CPU, the GPU, the memory, making them talk to each other very, very efficiently in a complex AR system, and you extract the efficiency in this way. This will lead to lower power consumption and extended AR user experience on a mobile device. And this is the essence to sort of lower power efficiency. Now that we've built the system, we can enable our partners to build a system like this, and we can actually build a low power system using an AR application running on this. But to give this to developers, you need something more. A wide community of developers need to build applications on a complex system like the big little CPU-like system. And for that, you need standards. And that's where Khronos has played an instrumental role in making the wide community of developers develop code on complex systems like these. So in this case, you can see the blue boxes show where the CPU is being used in a representative AR pipeline. And the green box shows you where the GPU is traditionally being used, such as the graphics rendering. To make the system more efficient, you identify, again, the parallel parts of the algorithm, and you move that over to the GPU side of things. And for that, Khronos has been instrumental in creating the Opencl API, which now allows me to offload some of the compute-intensive algorithms over to the GPU. And for this, we need the Opencl full profile that Khronos provides, which has been very useful in this case. So this shows you, again, a representative AR pipeline where we can run the system efficiently by offloading some of the compute-intensive tasks on the CPU over to the GPU, thereby getting a low power profile and running the system more efficiently. But in order to make the system more, sort of the AR market more commercially and technically successful, this is not enough. You need something more on top of this. And that is how to enable an AR ecosystem. The ecosystem is really, in this case, a value chain. As you know, ARM powers most of the devices in the world today when it comes to the mobile devices. And my previous speakers have also mentioned that our success is built on partnerships, and we enable our partners to build efficient systems. And we've been a part of the value chain. But if you look at the AR value chain, there are more participants there. When you look at developers, when you look at content providers, when you look at retailers, there are a whole number of people. And for AR to be successful, you have to look at how do you create value in each aspect of this AR value chain. The first thing we have done is to enable our partners to build the efficient and smart system. So we provide them the tools, the libraries, and we will also provide them the system to actually build an efficient compute subsystem. This compute subsystem, in turn, goes to our close partners who have listed here, who are also here at MWC, who use these compute subsystems to optimize their middleware. Now, in the process, as you can see, you are optimizing the whole value chain in terms of an efficient subsystem, an efficient middleware, and this efficient middleware is then provided to a wide community of developers. These developers are the developers who create augmented experiences. They created the applications we've been talking about. Is there a killer app? These are the people who are going to create the killer app, or they'll create something new. So far, we can create a chain of efficient computing, efficient middleware, and the middleware providers can then in turn give these systems to a wide community of developers who in turn will create the augmented world that we've been talking about and making this successful. Given that ARM is in the middle of all this, trying to influence the whole value chain, we will closely monitor and work with our partners to influence the next generation of AR platforms So this will be a chain which will go on until we find complete maturity in the AR value chain. In summary, how do we enhance the AR value chain? How do we enhance the AR ecosystem? Is that the first takeaway for me is that AR is here. It works. There are applications. And please stop by our booth today. We have exciting and immersive experience from our partners like Metaio, OlaWorks. There's some very interesting demos that you can see which apply to the outdoor world and the retail space, which could lead to where AR should go in the future. But there are some challenges that we have to face, which is power consumption for sustained AR experience. And this is something we are actively addressing at this point. Khronos, as I mentioned, has been instrumental in providing the standards so that a wide community of developers can use our complex platforms to create content and applications that will go out to a wide community of users out there. But as you know, ARM's success is built on partnerships. We have a wide community of vibrant sort of ecosystem developers, a wide community of developers on the CPU side and the GPU side. And we have worked with the GPU side of the developers to optimize the graphics rendering, and we continue to work with the CPU side to actually optimize their CPU side workload. But one thing key about ARM is that you have the CPU and the GPU, and on top of that you have the coherent interconnect that I spoke about, and on top of that you also have the physical IP that we provide, and all of this comes from one house, which is ARM. The reason this becomes more and more important is that as we go forward, it's not just a question of whether CPU is running well or the GPU is running well, or how big my die size is, which is becoming a problem. It's really a system problem that we have to solve. And as GPUs become bigger and bigger, they are occupying more of the die size, which means you cannot view these components in isolation. You really have to look at what's running on the CPU, what's running on the GPU, how big is my die size, how much time am I spending on this part of the die. You have to really look at it as a system problem and try to solve it as one whole problem and not just one element in isolation. And as I spoke about building smarter and more efficient systems, we are working with a vibrant ecosystem of AR developers, AR middleware providers, silicon vendors who are working together to create a vibrant AR community going forward. Thank you very much.
Thank you, Shri, for that insight into how ARM is enhancing augmented reality in the mobile space.